Hello, everybody. I'm RJ.
My name's Rohil.
I'm Maddox.
And today we're going to be covering conic applications. So we already know that a conic section is any curve created by the intersection of a flat plane and a three-dimensional cone. This can create a multitude of shapes, such as circles, parabolas, hyperbolas, and ellipses. Specifically, today we'll be covering how to apply this to the real world.
First, we have our first circle example. I'll give everyone 10 seconds to read the question. All right, to start, we have to remember our original circle formula, which is x squared plus y squared equals r squared. To start, you should create a sketch to help analyze the problem. So here is our semicircle tunnel. Our radius is given as 12 feet, and as told, the street has two lanes, each 10 feet wide. Now that we have our sketch drawn out, we can understand that our exit is equal to 10, so we can plug this into our equation. And we're also given our radius, which is 12 feet, so we can also plug that in. Now we can simplify this equation to be given what y squared equals. We remember to square both sides. So y equals root 44 or 2 root 11, which is also equal to 6.63 feet as your final answer.
Okay, for our next problem, we have an ellipse. So take 10 seconds to read the question. Okay, first off, we will start with the equation, which is x squared over a squared plus y squared b squared equals 1. Next, we will draw a diagram to help us sort out this problem. So we know that it is 46 feet tall, 97 feet long. Then we can find our A and our B, taking half of these distances. And then just plug that into our equation. Which then gives us
Go.
While doing these problems, make sure that A is always bigger than B in this equation. Next, we have to find the foci. So the foci equation, c squared equals a squared minus b squared. We can just sub our numbers in that we already got. And now, to find the distance, we should divide by 2. Oh, wait. Oops, I meant to say square root, not divide by 2. But after we do that, we would get 85.4 feet as the distance.
Okay, so now we're going to be talking about an hyperbola example. So I'll give you 10 seconds to read this question. Okay, so now we need to write our standard equation for a hyperbola. And notice that this one opens left and right. So we need to put our x first. And this is minus instead of plus. Okay, so now we need to put in the numbers that we have. So we need to find how wide the sculpture is at a height of 5 feet. So we can actually just plug in one of our points to help find b squared. And after simplifying this top bit, we get negative 169 over b squared equals negative 3. To isolate b squared, you multiply b squared to this side and then divide by negative 3. So b squared is equal to 169 over 3. Now we can put this back into our original equation. Okay, so we want to find the width of the sculpture at a height of 5 feet. So we're going to plug in 5 for our y. And then we simplify.
Can I pause and resume the voiceover? I don't know. Like I can edit your voiceover.
So now this is equivalent to 24 feet. Okay, so we know that this one is going to be parabola example, but I'll give you 10 seconds to read the question. Okay, so we know it's a parabola example, so we know our equation from previous lessons is going to be x minus h squared equals 4p and then y minus k. Okay, so this hint right here tells us that our dish or the vertex is going to be at 0, 0. So we'll start by drawing that. We know that it's going to be 10 feet across, so it's going to be 5 feet this way and 5 feet this way. And then we also know that its opening is 4 feet deep at its center. So we know that this, since this is 0, 0, label that, we know that since it's 4 feet deep from its center, it's going to be 4 up here, 4 feet up this way. And since it's 5 and 5 this way, that's our 10 feet across. So then we have this point, 5, 4, and negative 5, 4. Okay, so we want to know where the P is. So the focus is going to be somewhere in there. So now we can use our equation and plug in our numbers. So we don't have any x translations because we're at 0, 0. So, and we also don't have any y translations because this vertex is at 0, 0. So we have x squared equals 4py. Now we can just sub in one of our points to help find p, because p will tell us the distance that the foci is from the vertex. So we can sub in our numbers. 5, 4p, and 4. I'm just using 5, 4 so we don't have to use a negative here. So we have 25 equals 16p. And to isolate p, we just divide by 16. So p is telling us that our distance is 25 over 16 feet from the vertex. Now that we know the distance, we can actually just label the point. So since we're moving 25 over 16 from 0, 0, we know that it's going to be located at 0, 25 over 16. Okay, so for each of these questions, what you really want to do is you want to sketch out what your actual situation is first. And you want to note that you're always going to be using one of these four equations: your hyperbola equation, your parabola equation, your circle equation, and your ellipse equation. And then more often than not, you're given a majority of the information you need to, first of all, sketch the questions, and then being able to plug in what you're given to find your unknown, which will help you find your real world solution. Okay, so hyperbolas are probably the most confusing out of the four. So here's another example problem. I'll give you a couple seconds to read this one. So first we're gonna start out with a sketch. So from the question, we know that the tower stands a total of 160 feet tall. And then it's symmetric at a halfway point. So our halfway point is gonna be put at 0, 0. So it's gonna look like this. And we also know the diameter are 60 feet apart at the very center. And then the diameter at the very top of the tower is 100 meters. So the question wanted us to find the standard equation. So our basis for that is x squared minus y squared over a squared and over b squared equal to 1. So now we can just plug in the numbers. Okay, so to find our x squared, we need our horizontal distance. That's not what that means. So these distances tell us that the halfway point here is 50. These are each 60. And that the halfway point here is 80. So we can actually get some points, and we're gonna plug those in. So we have 50 squared minus 80 squared over our a squared and b squared. We know our a squared because this is a horizontal opening hyperbola. So we know that the a squared is gonna come first.
Nice, RJ.
Right. So this whole thing is 60. So we can actually find that the halfway of this is 30. So it's 30 meters apart there. So we actually know our a squared, which is going to be 30 squared. So actually I'm just gonna rewrite that in here. And now we simplify. This is gonna be 2,500. This is gonna be 900 minus 6,400. And we don't know our b squared. So that's what we're solving for. So first we have to try and isolate b, but we can actually simplify these big fractions first. So we get 25 over 9. And then I'm actually gonna move this over here. I'm gonna add this to this side and subtract this one to this side to help us isolate b. So minus 1 equals 6,400 over b squared. Now if we continue to simplify this by subtracting this 1, which is really 9 over 9, we do 16 over 9 equals this big fraction. Now we can cross multiply this. So first we're gonna multiply this way. So b squared times 16 is equal to 9 times 6,400, which is equal to 57,600. And we can divide both sides by 16, and we get b squared equals 3,600. So that can go back into our original equation if we want to solve for anything else. So now kids, I'm going to challenge you to find the width of this hyperbola at a height of 70 feet. Now that we've covered a few examples, you now know how conic sections can apply to real world situations and scenarios. Make sure you memorize your 4 equations and be ready for the test.